Good evening and welcome back to another session of data structures and algorithm class. In today's session, we will discuss the circular queue using array. In this session, we'll implement circular queue using array in C programming language. In the previous videos, we have implemented the queue using the array, linear queue using the array. So the problem with the linear queue is that suppose this is the linear queue. It has 6 elements. Initially, we know that we initialize front and rear variables with -1. These front and rear variables are used to store the index of the front and rear variable, right? So basically what happened, insertion in the queue is done through the rear side, insertion through rear side, and deletion is performed from front side. Now let's write some sequence of operations. Enqueue 5, enqueue 10, enqueue 20, enqueue 40, dequeue, again dequeue, enqueue, suppose 15, enqueue 30. Let's execute these operations on this linear queue. Initially, both our front is equal to rear is equal to -1. When the first element comes, the value of both front and rear becomes 0. Front and rear both are now pointing towards the this element. The value of both front and rear is 0 now. Now when the second element comes, the rear become, let me write the values of front and rear here. First, initially they were -1, then the 4 becomes 1 when the first element come in the queue. After this, when the second element come, rear becomes 1. After this, 20 comes and the value of rear becomes 2. After this, request to enqueue 40 comes and the value of rear becomes 3. After this, dequeue, there are two dequeue operations. So front becomes first, the value of front becomes 1. This item will be deleted, and after this, front becomes 2, and this value will also be deleted, right? Now we have request to enqueue 15. This will make rear variable to hold the index of 4, and finally 30. Now suppose there comes one more request to enqueue an element 50. Even though here, even though we have two empty spaces in the array, the 0th space and first index, but we cannot insert this value in our queue, and this will result in the queue overflow, right? So in order to tackle this problem, we have introduced circular queue. In the circular queue, we can insert the element when the one side of our array is uh, full. We can insert the elements from the other side, right? And logically, it is represented like this. So, if we execute the same operations uh, in the circular array, then first will enqueue enqueue. Here also both initially both front and rear will be -1, indicating that our queue is empty. But when the first element come, both front and rear will be will become 0. After this, we have an enqueue request of 10, so rear becomes 1, then 20, 40. So last value of rear becomes 3. Then we have 2 dequeue request, which will make front move to here, 1 and 2. These values will be deleted, and after that we have 2 enqueue request, 15. 15 will be inserted here, then 30 will be inserted here, and 50 here. So this way, circular queue is able to uh, overcome the problems associated with the linear queue. Now let's see how this happens. How will be able to do this? Suppose if the size of this queue is 5, the maximum number of elements this queue can hold are 1, 2, 3, 4, 5. So we can say max is equal to 5, or size of the queue is 5. Then our rear pointer will be incremented like this. When we increment our rear pointer, then rear pointer will be incremented like this. Rear is equal to rear plus 1 and modulus size for max. So when uh, the value of rear becomes 4, so rear will become, the next value of rear will be 5 modulus 5, which is equal which is equal to 0. So again we'll come to the 0th position of the array. So this way it works, and now we will discuss the operations on circular queue one by one. So as already discussed, uh, we'll have the same operations in the circular queue also. We will implement enqueue, void enqueue, to insert an element in the queue. We'll also implement dequeue to delete an element from the queue. But before this, to check the overflow and underflow condition, to check the overflow and underflow condition, we will create two methods. Int is full. These methods we are creating to check the boundary conditions, and int is empty, right? So when will our queue will be full? Our queue will be full when, see, if this is a circular queue, so our queue will be full when our front value, when the front value will be equal to when the front value will be equal to rear plus 1 modulus max, right? So you think about this. We'll return the here, return front equals rear plus 1 max. So this is a conditional statement. This will return 0 or 1. As if the condition is true, this will return 1. If the condition is false, this will return 0. Likewise, when will our queue be empty? For the empty condition will be uh, same when the front value is equal to -1. So here we only need to check. We will return if front is equal to -1. So it is so simple. So let's implement our enqueue operation. Int enqueue, and this number we will insert in the array. So as already discussed, when we are trying to insert some element in the queue, we will first check for the overflow condition, and for this we have already created a method is full. This will check if the queue is full or not. If it returns true, means 1, we will print queue overflow or queue is full, and sorry, this enqueue operation will not return anything, so we will use void here, return. Then we have to check if the number element we are inserting is the first element. If front is equal to -1, because what happens when we are inserting an element, it goes to, we increase the rear pointer, rear variable. But if it is the first element, then both front and rear should point to the same element. So here we need to, if it is the first element in the array, in the queue, we need to set the front variable also, and we will set the value of front variable to 0. After this, we will calculate the position of rear as rear is equal to rear plus 1 modulus size or max. This is the maximum size of our array, and here we will simply uh, you know assign the value q rear is equal to n, this value, and this completes our enqueue operation. You can see there is not much difference in this implementation and the linear implementation. Now the next they looks almost similar. Now the next method is dequeue. This dequeue method is used to delete the element from the front. So we will first check for the boundary condition, that is boundary condition means we will check if the queue is empty. So we already have a function to check if the queue is empty. We'll simply call it if is empty, simply print queue is empty, or we can also print queue underflow, whatever you like, and return -1 here. Now store the front element of the queue in this variable data queue front, because we will return this value to the caller. Now we need to check if the queue contains only the one element, because if it contains only the one element and we are removing the last element of the queue, we will set the front and rear variable to -1. So here, if rear is equal to front, what does it mean? It means queue has only one element, right? So in this case, what should happen? We will set both front is equal to rear is equal to -1. Else we need to set the value of front variable, and our front will become front is equal to front plus 1 and modulus max. And finally we will return this data, return data. So this is our dequeue operation. Now we will implement the display method. Void display so again in the display method we can check if the queue is empty, because if the queue is empty there is nothing to display. If is empty, we'll simply printf queue is empty, and therefore we can return from here. Otherwise what we can do, see, we will start from the front. Let's take a variable and I is equal to front. We will start from the front and we will stop when the front is equal to the rear side, right? So we'll start from the front and let's use an infinite loop and print %d q I. Let's print the element of q. If front, I'm sorry, I. If I is equal to rear, then what should we do? We should break the loop, because we have printed all the elements of the queue. Otherwise, what we have to do, we will recompute I as I is equal to I plus 1 mod max. So that's it. This is our while loop, and our display function. You can also implement the peak operation if you want. In peak, so in the peak operation, simply check if queue is empty, then print queue is empty. Just a second. Otherwise, what we need to do, return -1. If it is not empty, then simply return queue front, and that's it. So this is the circular queue. What is the advantage of using circular queue over the linear queue? If we are using the circular queue, we can utilize the space already dequeued by the dequeue operation, right? So this is the advantage. So thank you very much. I hope uh, this explanation has cleared your doubt. Okay, before leaving, let's try to run this code. So in order to save the time, I've already written the code here, and the code is exactly same that I just discussed. We have defined the maximum size of the queue, then we declared a queue of size 5. We have initialized two variables, front and rear. Initially they are initialized with -1, that indicates that the queue is empty. Then we declared two functions, is full and is empty, which are simply checking the boundary conditions if the queue is full and if the queue is empty. Then, as already discussed, whenever we try to insert some element in the data structure, we always check uh, if the data structure is full, if the queue is full. So we always check for the boundary condition. Then, if it is not so, if the queue is not full, we'll check if the element we are inserting is the first element. Because if it is the first element, we will set the rear variable. But what about the front variable? Front variable we have to manually take care of like this. If it is the if it is the first element, then we also need to set the value of front variable, because if there is only one element in the queue, uh, then both front and rear variable will contain the index 0. After this, we have simply increased the value of rear like this, and then we assign our given value at this designated position. Simply, while dequeuing the element from the queue, we first check for the boundary condition, and here also, if the queue is left with only one element, then and we are removing the last element, then we need to set the front and rear variable to contain -1, because in this case our queue will become empty. Now, since we already know that we remove the element from the front, so we will increase the value of front as per this formula. The only change here is this modulus sign if we compare the circular queue and the linear queue. And after this, we will return the data dequeued from the front side. Then this is our display method, and we can also implement display method using the for loop. We can write this in one single line. While I is equal to front, I less than equal to I is equal to rear, and I is equal to I plus 1% size. Right? We can write this in the single line. In the main method, what we have do, we have enqueued some elements, then we displayed the queue, then we deleted the element, we again displayed the queue. Like this, we performed some operations. Let me run this code and show you the output. You need to carefully monitor the output. First, we have enqueued 14, 22, 13, and 6, and print the queue. So the output is 14, 22, 13, and 6. Then we delete the one item from the queue, and the deleted value is 14 because 14 is our front element. Then after deleting 14, our queue contains 22, 13, and 6. Then we enqueued two more elements in it, 9 and 20, and they are displayed here. After this, we displayed the queue, and we are further trying to enqueue some element. But since the size of our queue is 5 and we have already enqueued 5 elements, the queue is full now, and the boundary condition is printing here. So thank you very much. I think this has cleared your doubt regarding the circular queue. We'll see you again in the next video of data structure and algorithm. Till then, bye bye. Thank you.